Hi, my name is Annelah and I'll be walking you through our software development source files. So when you first clone this project for the first time, you'll be greeted by a README file. So README file acts as an orientation for someone who's looking at our code for the first time. So this README file will include like a very descriptive description of what our code does, the installation process, and the testing process. So this is almost like a guideline to someone who is new to our code. Okay, so over to this side, we have our source folder inside our Brownfields project. And inside here, we have our client folder, which has the different types of robots. And we also have the database. The database helped us to save and retrieve and also update our any data that is related to the robot worlds. And we also have our mock folder. This has our robot world interface and our robot world client class. So inside the server, we have a majority of our folders. We have the application programming interface, the different commands that are related to the robot worlds. We have the communication as to our data communications with the robot. We also have different types of obstacles within the world, and we have our robots. This is our main server, so this is where we run our server. And we also have our server manager, which also manages what happens inside the world, which is the server. We also have the web API, and we have the world itself. Okay, so in addition to that, we have our POM file. So our POM file is an XML file that contains information about the project and configuration details. These details and configurations are used by Maven to build the project. Next, we have our Docker file. Docker builds images automatically by reading instructions from this Docker file, which is a text file that contains all commands in order that are needed to build a given image. A makefile is used to compile our program, our robot world program, from source code. Okay, so lastly, we have our test folder. So in our test folder, we have our unit test and acceptance test. These tests are very useful in our development process because these tests ensure that our code is of high quality and they meet a standard, and to also ensure that our code base is working as it should. So these are the test files that we have, and these are the tests that we have. Okay, so over to GitLab. During our time at Within Code, we were introduced and were taught about version control. So the specific version control that we used at Within Code was called GitLab. So in front of you, I've opened GitLab and I will walk you through our procedure that we followed according to Within Code. So first things first, we have different branches inside the main branch. So each and every person had their own branch of which they can push into, make changes, and create commits into it. And then after that, we're able to merge each branch into the main branch. So the purpose of having different branches is to make sure that whenever someone is updating their code base on their branch, it doesn't affect the main branch and it doesn't break what's happening in the main code. When it comes to merging, currently there's no merge request opened. Each person would create a pull request, and one person would review the pull request and also merge it into the main code base. So in order for you to create a merge, you have to make sure that the tests are passing and the standard meets the standard of the entire code base. Next, we also have our CI/CD configurations. This is for our pipeline, and this is our pipeline. It's currently passing. So this is for deployment when we want to deploy our project. Version control is very useful for protection of corruption in files. It also helps manage and retrieve code. We can also do this separately in different branches from the main branch and then merge it into the main branch, right? And also it's for protection of lost. Maybe a file was corrupted, it can be retrieved, you can backtrack into the previous commits and so forth.
Greetings and welcome to Section B of our presentation. My name is Tshepang Ndlovu and I'll be taking you through our code and design conformance. The Robot Worlds Brownfields project entailed of having to program into an existing code base with the objective of changing that system's functionality or adding new functionality. We were given specific instructions for the project, and they are as follows. We had to learn and understand how to develop systems in Brownfields environment, analyze an existing code base to understand its technical debt and figure out ways to repair it. We had to improve code quality through refactoring. We had to design and implement a database using SQL, and I had to implement a CI/CD pipeline to integrate code changes and deliver updates. The code base that was given to us was a Java application simulating a virtual world that could be inhabited by robots. These robots would be able to perform different kinds of actions within the world. In order to install the program, you need to clone the repo from GitHub. You need to then navigate to the project directory, compile the source code, and then you can run the application using Java. You do need to have JDK installed on your system, as well as Maven, and also the SQLite database management system. The architecture of this program is a client-server architecture, where the server side of things is responsible for the world and what happens within that world. So things like your client request, the state of the world, objects within the world, how many robots are in the world. The client side of things is responsible for anything that has to do with user interaction. And the database side of things was responsible for data management, accessing the data, retrieving the data, as well as data manipulation. In order to use the program, you need to start the server, connect the client to the server, launch the robot into the world, and control its actions using different kinds of command statements. You're going to do all this by using an input statement on the console. To test the program, we use different kinds of testing methods. We used the acceptance testing method, which used different kinds of scenarios to test the functionality of the system. And then we used unit test, which focused on individual components of the functionality of the system. Okay, so now I'm going to take you over to the code just to go over a bit of code demonstration. So like I said earlier, our code architecture follows a client-server architecture where we have different kinds of folders. And within those folders, we have different kinds of files that do specific roles or specific duties. So in our source folder, we have our main folder, which has most of our code. And like I said, different kinds of files and folders follow or do different kinds of things. We have our client folder, which deals with anything that has to do with the robot. And this basically happens in this file, robot.java file. And then we have our server folder, which has everything that has to do with the world. So connecting to the server, also running the server, as well as different kinds of server commands as well. And then we have our database folder, which contains our DB connect file, which is where we connect to SQLite, and we also create tables to store different kinds of information like the world, the obstacles, and the robots that are within the world. And yes, and then we perform different kinds of data manipulation, like inserting data within those different kinds of tables and accessing the data as well. With that said, we assessed the need to have a test strategy put in place, and we decided that it is very important for us to have a test strategy because of the following reasons. A test strategy ensures data integrity by verifying that data manipulation operations maintain integrity and accuracy. It also maintains the functionality of the program by confirming expected behavior of the program in response to various inputs and scenarios. It also takes care of error handling by identifying and validating error handling mechanisms within the program. It also looks at scalability by assessing performance of database operations under different load conditions. It also maintains security by ensuring adherence to security best practices and compliance requirements. It also verifies that existing functionality remains intact and unaffected by any code changes. We then had to implement a test strategy, and we're going to be testing different kinds of components within the program. So we're going to be looking at unit testing, which tests individual components and functions in isolation to verify their correctness. We're going to be doing integration testing, which validates interactions between different modules and components. We're going to be also performing a performance testing, which assesses the application's performance under normal and peak loads. We're going to be also looking at functional testing, which verifies that the application functions as expected from a user's perspective. We're going to be looking at regression testing, which ensures that new changes do not introduce regressions in existing functionality.
Good day, ladies and gentlemen. My name is Keitumetse Molefe, and I'll be walking you through our code and design conformance part of our project. A description of the project's purpose. This is extracted from our documentation. The purpose of this project is to learn and understand how to develop systems in Brownfields environment. Number 2, analyze an existing code base to understand its technical debt and figure out ways to repay it. Number 3, improve code quality through refactoring. Number 4, design and implement the database using SQL and relational database management systems to allow users to store and retrieve data from database. Number 5, implement a continuous integration and continuous delivery pipeline to integrate code changes and deliver updates to users as early as possible. Our documentation layout design. Our documentation layout design is designed in such a way to allow users and developers to effectively analyze and understand its purpose and core functionality. As you can see, our documentation layout is designed in such a way to help developers understand its purpose and its core functionality. For our testing, we use JUnit 5. JUnit 5 is a testing framework that allows developers to test Java applications. For our project, we have 2 sets of tests, which are our acceptance test as well as unit test. Now, our acceptance test, these tests verify the system behaves correctly from the user's perspective. They also cover scenarios such as launching robots, querying robot states, and handling errors. And our unit testing, they focus on testing individual components such as the commands or server logic and client-server communication. And now I'm gonna walk you through one of our tests. As you can see, our code is commented, and each comment specify what each test does. As you can see, even this one, each and every test case is commented.
Hi guys, my name is Livhuwani Rannuenueni. Today I'm going to be talking to you about database management systems. Database management systems is a software system used to store, retrieve, run queries on data. A database management system serves as an interface between an end user and a database, allowing users to create, read, update, and delete data in the database. Problems represented by data management issues: data quality, data privacy and security, data loss, and corruption. Data quality. Data quality problems arise from errors such as inaccuracies and missing data, causing mistakes, wasted resources, compliance issues, and distrust. These result from poor management, inadequate cleaning, and user errors. For example, incorrect customer addresses causes delivery problems affecting business decisions and customer satisfaction. Data privacy and security. Data management issues such as poor oversight can worsen compliance violations. For instance, if a company lacks proper protocols for handling customer data, they might inadvertently share sensitive information and violating regulations. This breach not only risks legal penalties but also damages the company's reputation and erodes customer trust. Data loss and corruption. Data loss and corruption in data management entails the risk of losing critical data due to hardware failures or software errors. Without adequate backups and recovery plans, organizations face disruptions and potential permanent loss of valuable information. Solutions represented by data management issues. Data quality. Ensure accuracy, completeness, and consistency throughout regular data cleansing and validation processes, establish data governance practices, and provide user training to maintain high-quality data standards. Data privacy and security, implement robust access controls, encryption, and monitoring to safeguard sensitive data from unauthorized access, conduct regular security audits and employee training to mitigate risk and ensure compliance with regulations. Data loss and corruption, implement comprehensive backup and recovery strategies to protect against data loss due to hardware failures or corruption. Regularly test backups and monitor systems for potential issues to minimize downtime and ensure data integrity. Features of database management systems contributing to solving data management issues: scalability, compliance, data consistency, and security. Scalability: commercial database management systems offer scalable solutions to accommodate growing data volumes and user demand, ensuring that organizations can expand their database without compromising performance or scalability. Compliance: commercial database management system helps organizations meet regulatory requirements and industry standards by providing features and tools for data governance and sales and compliance reporting. Data consistency: commercial database management system maintains data consistency across multiple databases and transactions, ensuring that changes are properly synchronized and validated to prevent data corruption or loss. Security: these systems prioritize data security, implementing robust measures to safeguard sensitive information against unauthorized access, breaches, and other security threats. Types of database management systems: we've got relational, NoSQL, object-oriented, graph, in-memory, and distributed. Relational database management systems: data organized into tables with rows and columns. Data is accessed use structured query language known as SQL. Supports ACID, which is atomicity, consistency, isolation, durability, transactions. Ensures data integrity through constraints and relationships. Example: MySQL is a popular relational database. NoSQL database management system. This is designed for handling unstructured, semi-structured, and structured data. Flexible schema allows for dynamic changes to data structure. Scalable horizontally, making it suitable for big data applications. Supports eventual consistency model. Example: Mongo database is an example of a NoSQL database. Object-oriented database management system. This stores data as objects, combining data and methods which are functions to manipulate the data. It supports complex data structures and relationships, allows for inheritance, encapsulation, and polymorphism. This is well suited for object-oriented programming languages. Example: DB4O is an object-oriented database management system. Graph database management system. This organizes data as nodes, edges, and properties to represent and store relationships. Optimized for traversing and querying complex networks of relationships, suitable for applications like social networks, recommendation systems, and network analysis. This offers efficient graph algorithms for analyzing and manipulating graph data. Example: NEO4J is a graph database that uses graph structure with nodes, edges, and properties. In-memory database management system. This stores data primarily in main memory rather than on disk. It offers extremely fast data access and retrieval, used for real-time analytics, high-frequency trading, and testing. This requires large memory capacity and may be expensive. Example: Redis is an example of an in-memory database. Distributed database management system. This spreads data across multiple interconnected databases or nodes, offers scalability, fault tolerance, and high availability. Allows for distributed transactions and data replication using cloud computing environments and large-scale distributed systems. Example: Apache Cassandra is a distributed NoSQL database. Database management system. End-user tools. End-user tools are software applications designed for non-technical users to interact with databases. Examples of end-user tools are query tool, reporting tool, data entry, and data modeling. Features and limitations. With the query tool, there is a user-friendly interface for writing and executing SQL queries. The feature is that it has syntax highlighting, autocomplete, and query formatting for improved productivity. Limitations: limited support for visualization, complex relationships, or hierarchical data structures. A reporting tool is a software application or platform that enables users to create, format, and distribute reports based on data stored in a database. Feature, drag and drop interface for creating formatted reports and visualizations, limitations, performance issues with large datasets or real-time data updates, and may lack advanced data analysis capabilities compared to dedicated analytics tools. Data entry tool, customizable forms for structured data entry into the database, feature, validation rules, and data integrity text to ensure data accuracy. Limitation, limited support for dynamic form generation or conditional logic. Data modeling tool, it is a graphical interface for designing and visualizing database schemas. Feature, entity relationship diagrams, ERDs for modeling database structure and relationships. Limitations, limited support for forwarding, engineering, or generating database scripts. Data access requirements. This develops an efficient system for managing robot world data stored in the SQLite database, accessible through a user-friendly web interface as well. It ensures data integrity, provides data analysis capabilities, and implements a formatted backup for continuity. This designs the system to scale and accommodate future growth. The objective is that to create a high-performing web system utilizing SQLite for efficient data retrieval, responsive interface, optimized queries, data integrity, and resource utilization. The critical performance factors, this includes efficient data retrieval from SQLite, responsive web interface, optimized query execution, data integrity measures, and resource utilization. These ensure minimal latency, consistent database performance, and smooth scalability. Automated backup processes must run seamlessly to prevent disruptions. Prioritizing these factors guarantees a high-performing system, providing users with a seamless and efficient experience when accessing and managing the robot world data. Thank you.
Our users required a system that would allow them to perform crude operations, i.e., store and retrieve data to and from a database. And our system as well had data that needed to be stored into a database. Now, to solve these problems, we've implemented a database design structure that would allow our system to store user data and system data into a database, and thus reducing data loss. This is our UML diagram, which basically depicts a high level of our database design structure. We've designed our system in such a way that our clients do not have direct access to our database, thus reducing the risk of having SQL injection attacks as well as brute force attacks. Our database structure has 3 tables, being the world table, the robots table, as well as the obstacles table. The world table has a primary key as well as 2 foreign keys, which indicate that these 2 entities reside in the world. Our world has a one-to-many relationship with both entities, that is the robots table as well as the obstacles table. And both entities, the robots table as well as the obstacles table, have a many-to-one relationship with the world. Now, what this means is that only many robots can exist in a world, as well as many obstacles can exist within the world. But only a single instance of the world can exist, which has robots and obstacles in it. All of our tables are in third normal form to reduce data redundancy and ensure data consistency.
Hi, my name is Annelah, and I'll be walking you through section D, which is about evaluating SQL implementation and data. So I'll be showcasing the implementation of SQL into our program. And what I will do is I'll just point out a few lines where we have our initializing SQL queries. So in this method, we created our world table. We also created our obstacle table, and we created a table for our robots. So after creating our tables, we have to utilize those tables. So in other words, we have to store data into those tables. So what we did was we inserted our world data. So everything that is related, everything that is inside the world was inserted into the table. So we created a data query for that, and we inserted the world, so the world height, the world width, and the values assigned to it. And we also inserted our obstacles. So each obstacle had its own so each obstacle was inserted, and each obstacle had a type and a position inside the world, and it also had an ID. And this is where we caught errors. And then next we inserted the robots into the world as well. And then the robots had a name, a type, a position, and an ID. Okay, so after creating the tables and inserting the data into the tables, the last thing that we need to do is use that data. This is where we select the world data, and this is where we're also using it. So we're selecting all from the world and we're using inner join. So after that, we're getting the results from those selections. And for example, here, we're getting the ID, the height, the robot name, the robot type, and the obstacle ID types and positions. And then after that, we're just displaying it to the console. So to make sure that our SQL code was understandable, we made sure to create names that are clear, straight to the point, and describe what it does. Okay, so when it came to the use of SQL functionality that optimizes queries, one of the techniques that we used is indexing. So proper indexing can speed up the query execution by enabling the database engine to quickly locate the rows that meet the search criteria. On top of that, we reviewed and optimized the SQL queries for efficiency. So this included using the appropriate join types. So join, so for example, inner join, and also used where. And also avoiding unnecessary columns in selecting clauses and minimizing the use of functions.
Greetings to everyone. My name is Ongeziwe Hlazo, and I'm going to take you guys through our section E, which is task plan execution. We first set up a task board for the backlog. So the demonstration showcases the creation of task board on GitLab's named backlog for managing project requirements. The demonstration include adding features, which is stories, to the backlog as specified in the task plan. Any deviation from the task plan, such as changes in backlog items, are outlined during demonstration with explanations. The demonstration adheres to GitLab standards and procedures for task management and backlog creation. Refactor, Robot 12 server for acceptance tests. The demonstration include identifying relevant code server, modifying it to align with acceptance test specifications, and implementing automated acceptance tests. Automated acceptance tests is executed using predefined input data to validate server functionality. The demonstration showcases the identification and elimination of errors in the server code through successful acceptance testing. Analyze code base and identify top 3 hotspots. The demonstration involves installing and configuring CodeSyn, running an analysis on the code base, and identifying top 3 areas requiring attention. CodeSyn analyzes the code base using predefined algorithms and metrics without requiring specific input data. This is our CodeSyn. It shows the road spots shows areas, the hotspots that require our immediate attention. This is our CodeSyn after we're able to improve our code base and pay all the technical debts. So we're able to improve it from 9.6 to 9.8%. So right now I'm gonna take you guys through our backlog repository in the GitLab. So this is our Okay, right here is how we write stories and scenarios for each acceptance test. And this helps us to be able to eliminate errors that a user might come across while trying to run our program. So this is how we write each story for each command. So this is our issue bot. This helps us manage tasks and track each other's progress. In fact, the overall project scope, we use GitLab. We use the backlog repository to track everything. And yeah, that's pretty much it. These are our issues for each and every command that is in this project, and how far with each project, how far with each command, which one is in testing, which one is done, which one is in development. So this helps us to track the progress of the project as a whole. So right now I'm about to take you guys through our code to show the tests. Sorry. So let me take you guys through our launch robot test. So this is where we're implementing, as you saw in the backlog, this is where we're implementing the acceptance now, the acceptance test, and catering for each and every error that might come across when the user is trying to run the program. And it also helped us to fix any kind of bugs that might appear when the user is busy trying to run our program. So this is how we write our acceptance test here. And then so we have two types of tests. We have acceptance test and unit test. So we did the same with also our database. We have acceptance test for our database, and also have our unit test for database. So let me take you through the unit test for our database. So we connect our database to the SQLite database, so that it will be able to connect with our database like locally, and so that it's going to be able to use the SQL queries. And I'm going to be using Maven test to run to automate the running of testing process, so that I don't have to run each test one by one. Instead, this will help run all the tests at once, and it's gonna show errors. If there's errors, it's gonna show okay, skipped tests. Okay, as we can see right here, it ran about 51 tests, and zero tests are failing, and there is no errors, and also there is no tests that have been skipped. So the Maven test help us to automate the whole testing process, so we don't have to run each test one by one, but instead you can just run the Maven test, and it's going to run all the tests at once without having to do it manually, running each test one by one. This helps save time. So I'm gonna run the test multiple times just to show you guys that we get the same results even if we run our test multiple times. Let's run and see. As you guys can see, still it's success. Let's rerun again. It's kind of taking time. Yeah, again, so even if you run them multiple times, you still get the same results. Thank you.
Now I'm going to go straight into testing a few files. In order for you to test the functionality of the program, you need to make sure that your server is running and active. We are now going to test our acceptance tests. The following acceptance tests pass: launching of robots, the test to look around the world, the test to move forward, movement tests around the world, and state tests. We're now going to test for the database. The following test for the database acceptance test pass: the connection to the database SQLite, restoring the world and the data within that world, and saving the world and the data within the world. After each test has run, the test logs are then stored in our target file. This allows us to be able to access them whenever we need and review them. We use the test-driven development approach when developing our tests because it encourages us to review and improve our test process. To test that a specific test case only tests for what it's supposed to do, let's take into consideration the following. We've successfully connected the robot HAL to the server and managed to launch it into the game. Let's test for a movement command. To show that the tests are passing, it reports back by giving us a string of the following information. The result, OK. The data, message, is done. The state, it has currently 0 shields. It's at position 1-3, has 5 shots, and is facing the direction north with the status normal. Let's conduct another test. To show that the tests are passing, it reports back by giving us the same string with the following information. Result, OK. Data, message, done. The state of the robot is currently 0 shields at position 1 and 2, meaning it has moved forward 1 time again. The shots are 5. The direction is facing north with the status normal.
Hi guys, this is my report of the pre-design and outcomes of the documentation on the unit file. We had to let through transport and also execute some of the tasks at hand with the following iterations that we also had to do and assign them to each and every member of our team. Presentation identifies the documentation which was created according to the design plan. We use GitLab Passport to plan our iterations, assign tasks, and complete tasks, which serves as our defined design plan. Yes, the presentation structure document sensibly and defines how the program specifications has been made. The documentation is created according to the guidelines outlined in the review file on the GitLab, which ensures that the program specification has been made.